He's obsessed with the interaction of permaculture and data science. And he's working on a device to automatically weigh and count chicken eggs. So please welcome Mitchell.
Hello everyone, I'm Mitchell. I do some data science consulting. I predict the future for people with my company Nectric. And I'm going to talk about the software that I've created for R called Fable. If you do any time series analysis, you may have heard of this before. But if you haven't done much recently, you may be more familiar with Rob's package, the forecast library. So I'm going to start with a bit of a history. Rob was supposed to give this talk, but unfortunately couldn't make it. So he was going to talk about 30 plus years of his experience in open source. Now, I don't have 30 plus years of being alive, so I'm going to give a condensed version. Starting in the turn of the century, we have the TS package, which was brought over from S into R. And this brought with it many useful and fun time series functions, including TS, ARIMA, and everyone's favorite filter function. Now, Rob came onto the scene creating the forecast package, published in 2003, and he built on the work of the TS package with TS objects to add the ETS forecasting library, forecasting method, and theta forecasting method, and since has developed more methods which are used today in industry. Many years later, I worked on it in 2015, and essentially you'll see shortly that I tried to fix a bunch of the design problems, make it a bit more tidy, compatible with the tidyverse, but pretty quickly we realized that it wasn't going to work this way. So Eero was also working on the time series stuff at the time, and she created TS Tibbles. So Tibbles is bringing time series to Tibbles, which allows us to use tidyverse. Hands up if you're using the tidyverse. Most of you, wonderful. Hands up if you've made an R package or are making an R package. A few less. So I think this talk will be particularly useful if you're thinking about R packages, but it's also nice to think about the design of packages as well. So I started working on the Fable package in 2018, which is the natural successor to the forecast package, much in the same way that forecast built on TS. The Fable package has built on Sybil so that we can produce forecasts that are compatible with the interface of the tidyverse. And shortly after, the forecast package has been retired. It's no longer with us. We are still maintaining it. However, we're not adding any new features. So if you are using the forecast package, I hope this talk is a bit of a convincing story for why you might consider moving to Fable. So if you've made an R package before, you may be familiar with many helpful packages for making R packages. Some of these are here. So you might use this to get started, Roxygen to document your package, test that to add your unit tests, and so on. And maybe next, we'll hear from Jared about how large language models can build packages as well. But there aren't as many tools for designing R packages. Maybe large language models can help with this too, but there's not really any one answer for how to create or design a package. Sure, you can design a package that passes tests, that is well documented, but what makes it easy to use and learn? So the tidyverse does have some design guidelines that are published, but good design is subjective and is critically important for the adoption and functionality of your package. The principles proposed by the tidyverse is that it should be human-centered, meaning that we're designing for humans. Your errors and your hints should be very helpful and human-readable. It should be composable. We all love how we split the dplyr chain into various parts, and you can change the order to get different results. So composability is splitting it up into building blocks to solve the problem. It should be consistent. I hope this is self-explanatory, but if you do the same thing in two different ways and you get very different results, that could be very surprising. And inclusivity is important as well. And a big part of inclusivity is solved by addressing the previous principles, making it easy to learn, good documentation, makes it very accessible. So the design of the forecast package is different from the Fable package in a few ways, but the design of both packages are good for their purpose. So what were the goals that we're solving with the forecast package and the Fable package? The forecast package, developed much longer ago, was solving individual time series forecasting. Often you're focusing on some GDP figure or maybe income, and you just have a single time series that's only observed every quarter or year, and it's not such a difficult problem to forecast. Now, modern day time series, we collect large collections of time series, often very frequently. You might have 30-minute electricity demand, or you might have event data, like every time someone hires a city bike. That's a much more difficult problem to represent, and the time series class, the TS objects that the forecast package builds on, are just not suitable for this. So the forecast package focuses on single, regular, and infrequent observations, whereas Fable can work with any time observation. When producing some forecasts, it's interesting to see the nature of the forecast that you produce. The forecast package initially focused on just making a point prediction. What exactly did we expect to happen next into the future? And then shortly after, it added intervals, indicating some sort of uncertainty. The Fable package goes one step further, and we'll see why this is incredibly helpful. It actually gives you an entire distribution for what might happen next. And there's various benefits that you can compute from a distribution rather than just intervals. And lastly, forecast is designed around the TS objects, whereas Fable builds on Sybil, so that it's compatible and interoperable with the tidyverse. So I'm going to talk about some design elements on each of these packages, some mutual components, if you will, and how they differ between forecast and Fable, and hopefully offer you some tips for why I've made these design decisions for statistical software, and the tips that you might like to apply when designing or thinking and working with packages. So I'm going to tell this story with trips to Australia. And here I've simplified it a little bit, but essentially we have 4 main reasons for why people come to Australia. You can come for business, you can come for a holiday, you can visit your friends and family, or maybe there's some other reason. And every quarter, we count the number of people that have come to Australia for this purpose. And this is a common time series structure. If you've ever loaded in a time series dataset, a CSV or from a database, you may see your time variable, the quarter variable here, is represented with a date. You have this 01. You always use the first day of the month for some reason when representing quarters or months. But that's not very precise. To represent this data with forecast, you will need to convert it into a TS object. And TS objects on their own are a bit limited because they can only work with one time series, but we have 4. So to start, I'm just summarizing the total number of trips, regardless of the purpose. And because TS is built on vectors rather than data frames, I have to pull out that trips variable, so I get the vector, that column, and then I need to re-specify what the time variable was. Even though I had it in my quarter column, I cannot use it. And there's a lot of other extensions for TS that try to build and improve upon this, but TS, which is forecast-based, requires you to start all over again when describing your time structure, a very important part of your time series. Now, you also need domain-specific languages to work with TS objects. If you wanted to slice and dice in time, we use the window function. So I'm going to start from 2012,2. In this case, it's referring to quarter 2. But if I had monthly data, this would be February, the second number here too. So a bit confusing, multiple loadings of the same interface. Now, if I wanted to represent all of these 4 time series, there is a class for this, MTS, multivariate time series, and it's a wide format. And if anyone's familiar with the tidyverse, wide formats are a sin. we like our long format, and there's a few reasons for this. To get the TS object, we convert it to a matrix and then a TS object. But this is all trips data. What if I had something else? What if I had the amount of money that they brought to the country? Then I would have business count, business money, business something else. There's a lot of other variables, and we'll get something really wide that's hard to work with. So the TS format is very efficient and very minimal, and for the purposes of the forecast package, just forecasting single time series, it's a great choice. But in the modern day, it's not holding up. It doesn't work with multiple time series. You need domain-specific languages, and if you're familiar with the tidyverse, you need to learn a whole nother way of filtering time. And it needs to be regular. The Fable package, on the other hand, building on Sybil, is allowing you to work with something that looks very familiar, a Tibble. But instead, we act a bit more precise. Instead of having that 01, first day of the month representation of quarter, we have special classes for this year quarter. So there's a precise representation of quarters. And other than that, it looks and behaves exactly like a Tibble. You can use ggplot, you can filter, mutate, all of your familiar verbs. We add some extra information. The first row here, 1Q, represents that we have quarterly data, and this was automatically inferred from the quarter column. We didn't need to tell anything about the nature of the time. Now, to filter, to slice and dice, we can use familiar verbs. You've all used filter before. I hope that's very natural. And so when it comes to using or designing a package, it's much easier to learn a package if you already know half of the language. If you already know the tidyverse, it's not that much more to add as Sybil. You can still use filter to slice and dice. So as opposed to the TS format, the Sybil format has a lot of pros. It fixes a lot of the issues that the TS object has. With just one con, it takes a little bit more space. We're using a data frame here instead of just a sequence of numbers. So a takeaway from this is to design for familiar functions. If your users are familiar with the tidyverse, design around the tidyverse. If your users are familiar with TS objects, design around TS objects. What about modeling in R? So the forecast package has ETS, one of the first functions added, and this acts very similarly to stats arima, or TS arima, when it was first added. And if you have not seen time series modeling before, essentially we pipe in our TS object at the first argument, and then there might be a whole dozen of different arguments controlling the parameters and different ways you can model this. And you get a model object out of this. Can anyone guess what lambda represents in this model? It's very domain specific. If you're unfamiliar with forecast or time series, you would have no idea. So another tip from this is to design with terms that are self-explanatory. Don't be afraid to write long text that describes in detail what you're trying to do. Lambda is actually saying do a log transformation. Now, there are other models that forecast provides, TSLM, and this uses a different interface entirely. If you've used the LM function, the formula interface, it looks very familiar, but going between them, they have a very different structure. Now, a different type of model, or more accurately, a method in forecast, doesn't give you a model at all. It just directly gives you a forecast. And this can be very surprising. You think of seasonal naive as a model, but suddenly you skip one step and you get forecast. And this inconsistency can make it really hard to work with this software. I'll skip this for time. As opposed to Fable, we force all of these models to have a consistent interface, and we've chosen to go with the formula interface because this is what regression, cross-sectional analysis would be familiar with. And in addition, we've split up this step of taking your data and modeling it into two components, two building blocks that allows us to work with it in more situations. The first building block is the specification of the model, ETS, TSLM, and seasonal naive. The second building block is model, applying our model specification to some data and fitting the model. Now, the slide that I skipped is where it's really useful in Fable. We can use these building blocks as inputs to other functions or inputs to other steps. And because these are all functions, it's very extensible. Anyone can write their own STL function and put it in the model function. It's very extensible where forecast lacked. So some key differences between forecast and Fable for modeling. Fable has a consistent interface, the formula interface. It separates specification from fitting a model, and it allows any combination by doing this separation. You can apply models of models in very flexible ways. So think about designing consistent interfaces built up of very small components, very small building blocks to get a more flexible general approach. The third of four elements that I'd like to think about is accuracy. The accuracy approach in forecast, designed around a single forecast or a single model at a time, is quite good. You pipe it into accuracy, and you get a set of accuracy results. These are the familiar ones that forecasters like to look at, but they're not all of the ones that you might like to consider. And there's no ability to change what you get here. If you wanted to compute the accuracy for a different model, you do the step again and again. But a common task for forecasters is to see, I've got three models, which is my best model? And to compare this, you need to do 3 calls to accuracy. For Fable, because we have all of the objects in a single model class, we just pipe it singly into accuracy. And then we return a very familiar data structure, a tibble. We all know how to work with data frames. And if you've got large collections of models or time series, you can use ggplot, you can summarize, reduce this in any way you like in order to better understand which model is performing better. You can also specify your own accuracy measures, so it's extensible. Maybe you're working for a company and they have a specific KPI that they're interested in, and my software is not going to include that KPI for you. But you can create your own functions and use them directly with the accuracy in order to compute this KPI. Now, so far I've shown you a single accuracy measure for the total number of people coming to Australia, but it's so simple, much like Tidyverse, if you just remove one of the steps, you can get a different result. These are the building blocks that I was talking about. So if I remove this aggregation step, if I now consider all of the reasons why someone might come to Australia, I get a separate model for all of the reasons they come to Australia and a separate accuracy measure. So maybe we're more accurate at predicting holiday demand than business demand. Maybe one model is better than others for different types of coming to Australia. Maybe I wanted to see overall, across all of these 4 reasons for coming to Australia, which model performed the best. I can use dplyr. No new tools needed. So a couple tips from this, some key differences. The Fable package makes it a lot easier to compare across different models and across different time series. You can use the skills that you already have with the Tidyverse. It also supports custom functions for accuracy metrics. So if you have a specific KPI or a specific scoring rule that you like to use, you can bring that with you. So the tip that I'd like to give you for this element is to design extensible components, not just for other packages to make extensions like ggplot extensions that we all love, but also users. Try to design simple extension approaches that users can build upon. The final element that I'd like to consider is forecasts. The forecast package creates this custom forecast class. It looks like a data frame, but it's a list. It's a bit deceiving in that way. And it provides point forecasts and intervals. If you wanted to change the intervals that you get, you need to run the whole forecast again. Not great. To extract the elements from this forecast, you need to know what this internal list structure looks like. So we might extract the mean with $mean, the forecast object means element, the upper bounds in a matrix and the lower bounds in a matrix. However, this forecast mean contained in $mean, is that actually the mean of the distribution? Well, in this case, it's actually not. And this is where design can get really challenging, especially when you're building a package over a long period of time. Things change, we added transformations, and suddenly the mean that is contained in this object is actually the median, if you know your statistical theory. And to actually get the mean, you need to set bias adjust. And this bias ADJ is not very descriptive for what you're doing. What? So if I add bias adjust, I get the actual means. Hopefully we can do better than this for Fable. So in Fable, I'm applying the same modeling across many different time series, those 4. And you can see on the left-hand side of my formula, I'm specifying log instead of lambda. Very natural. I can also mix transformations. I'm doing log +1 here. And when I forecast not just the mean distribution that I get in the mean column, I get a trips column, which is an entire distribution. And you can see that this is a transformed normal. And sure enough, this mean is actually the mean of the distribution. Now, with the tabular format, the data frame, we can mutate, we can manipulate our distribution. So if you'd like to extract the median, you can call median of the distribution. If you'd like to get the intervals, you can compute the intervals of that distribution. You don't need to recompute the forecasts, you just compute on that distribution. So there's many other functions that you might like to use. You can extract the CDF, the quantiles, high-low, highest density regions. There's all sorts of tools available, and this is in the distributional package. So there's some key differences with forecast. It produces distributions, not intervals. It gives you a data frame so you can use the Tidyverse, and it avoids confusing terms like bias adjust. When you see mean, it means the mean. So use simple and descriptive terms. Don't try and shrink like bias ADJ, spell it out. And also provide outputs that are ready to use. When you predict from a linear model, you might get the mean and the standard deviation. You can't directly use that. You need to use R norm or D norm and so on. The distributions are ready to use. So in summary, we have the Tidyverse design principles, and some tips to achieve these is to build upon familiar functions. If your users are using the Tidyverse, utilize that skill. That will help them get a head start on learning how to use your software. Also consider to be internally, meaning consistent within forecasting methods or modeling, so you always get the same model class, and externally, so that you're consistent with other packages that you might work with. use building blocks to break the problem apart, and have simple descriptive names. So thanks for your time. Try forecasting with Fable if you haven't. It's easy by design. And chat to me anytime. I'd love to talk about R, forecasting, and chickens. Thank you.